Good day to everyone. So this is the third video in the series of layout diagram, and today we are going to see about how we can draw a stick diagram. So this is the expression we have been using for the last two videos. That is, first one, it is about how to draw a static CMOS diagram. So we have drawn a diagram like this one. The second video is about what are the rules you have to know before drawing a stick diagram that we have seen, and also we have seen the second step of drawing a layout diagram, that is to mark source and drain terminals of a particular transistor. So this is the last diagram we have seen so far. This is the step, and let me move on to the next step, that is drawing a stick diagram, right? So before drawing a stick diagram is one which differentiate each and every layer in a layout diagram, or each and every layer in a chip using different colors, right? So the basic difference between a stick diagram and a layout diagram is a layout diagram differentiates each and every layer depends on the thickness of the material, whereas in a stick diagram it will differentiate the material using different colors, right? So here I have mentioned some of the basic materials we are going to use. The first one is the polysilicon layer, so which is used to represent in red color. So I will write it down here. So red color, right? So the second one is about metal layer is mentioned or drawn in blue color, right? Wonderful. And the third one is about N diffusion, which is in green color, right? So on the next one is contact layer, which is in black color, and the last one is about P diffusion, which will be in yellow color, right? So everything is in order, so we can move ahead with the diagram of your given expression, right? So we can go ahead and draw your stick diagram. So first of all, we have to construct VCC and ground terminals, right? So this is your VCC, and the bottom you will have your ground or VSS terminal, right? So metal lines are the ones which are used to represent both VCC and VSS lines, right? So if you have to represent VCC and VSS, you have to use a metal line, that is blue color line, right? The second one is we have to draw a P diffusion line. So P diffusion line is drawn below that is P diffusion is one which is used to represent a P-type transistor. So P-type transistor will always represented below your supply terminal, that is VDD or VCC. So we will draw it below your supply terminal. So it will be in the yellow color, right? So this is P diffusion. Okay, right. So the next one is about the next one we have to draw is N diffusion line, which will be above your above your ground terminal or VSS terminal. So it will be in, this is nothing but N diffusion, right? So the next thing what you have to draw is polysilicon layer, right? So we have to form the transistors, we have formed the substrate material. So these are the two substrate, P-type substrate and N-type substrate. Next thing we have to form a transistors. So how many transistors we have to make? We have to draw 5 NMOS and 5 PMOS transistors, right? So transistors will be formed whenever a polysilicon line is crossing a diffusion line, right? So we have to use red color line, and so here it is a case, right? So we can draw your polysilicon line in any order, right? For example, in this expression it is taken, I am taking in the order A, B, C, D and E. So the polysilicon will be in the order A, B, C, D, E. So 5 polysilicon lines in the same order. So it is not necessarily the same order, but So there should not be any confusion after while drawing your stick diagram. So you can take up any order. So here I am using this order, right? So A, the second one is B transistor, third one is C, and this is D, and this is E, right? So we have drawn the transistor. The next step will be to mark up your source and drain terminals, right? So this particular region, this particular part is called as a fused part. So it means the terminals of a particular terminal of A and B is connected. So that is the meaning here, right? So from the static CMOS diagram, we have to look which two terminals of A and B transistors are connected. So here you can see, so this is the P-type transistor, so you have to look up at the PMOS transistor. Here A transistors, that is A transistors drain terminal and B transistors source terminal are connected together. So you have to take this as your drain and this as your source. So if this terminal is if this terminal is drain, this will be your source, and this is source means this will be drain. Okay, so then look up what is the next transistor to the B. It is C, right? So you have to check, so which terminal of C is connected to the drain terminal of B, right? So from this diagram we can see the drain terminal of B is connected to the drain terminal of C. So you have to take here drain, and this has to be source, right? So the next thing is the source terminal of C is connected to which terminal of D, right? So here the source terminal of C is connected to source terminal of D. So you have to take this as source, this will be drain, and drain of D is connected to source of S. So I will take this, right? So again this, if it is source, this will be drain, right? So beautiful. So we have completed your source and drain marking. So next we can move ahead with the connection, right? So from this you can see the source of A, C and D are connected together, and in turn they are connected to the supply terminal, right? So for this connection we have to use metal line. So that is blue color line. So let us see. So we have to connect source of A, right? So this is the source of A. So we have to connect it with which terminal? Source of C and source of D, right? So source of C and source of D is this terminal. So we can take up this like this, right? So you have to connect it with the supply line. So we have done it, right? So as per the second rule, as per the first rule, when two lines of same color match, so there will be a connection. So we don't need to provide any contact here. So whereas in this particular area we have to mention the contact. That is, contact is mentioned using a black color. So whenever two different layers or materials are crossing, we have to provide a contact. So we have done it, right? The next connection is, so this is already connected, and then we have to move ahead with this connection, right? Drain of C and drain of E are connected together. So drain of C and drain of E are connected, right? So we have to take up a connection from here, right? So we have to connect it with the drain of E, right? So they are connected to output terminal. So this is your output, right? So again we have to mark the contact layer, right? So the connection is almost over. So once again I repeat, so the first thing is about drawing your metal layers, one for your VCC and another one is for your VSS. The next step will be to draw P and N diffusion lines. P diffusion line will be drawn in yellow color and N diffusion will be drawn in green color, and this will be below the source or supply, and this will be above your ground terminal. And the next thing is to draw your polysilicon layer. You can make it up in any order you want, but only thing is there should not be any problem while connecting the terminals, right? So this is how we can draw your metal lines. So the upper part is over, right? So now we have to mark it your now we have to complete the connection in your N diffusion line. So as like what we have done for source PMOS transistor, we have to mark source and drain terminals for your NMOS transistors. So we have marked your source and drain terminals for all the transistors, right? So now we can move ahead with the connection, right? So since I hope you people don't have any confusions in marking the source and drain terminal, I have drawn this before itself. So let's move ahead with the next step. So now we have to make the connection, right? So from this diagram you can see we have to mark your or connect drain of A, drain of B to the output node. So drain of A and drain of B is this particular part. You have to connect it to the output terminal, so that is this line. Right, so like this you have to connect, and you have to mark, right? So one step is over. So the next one is source of A, source of B has to be connected to drain of D, right? So already here source of B and drain of C is connected. Only thing what we have to do is so that is this two parts are already connected in the stick diagram. Only thing is we have to take line from source and they have to connect it at this particular point, right? So like this you have to do, right? So you can draw it in the upper half also, but the problem is there will be a overlap of your metal lines, so it will create a short circuit, right? So you have to avoid those kinds of short circuits while drawing. So take care in drawing these things. So again you have to mark the contact, right? So the next thing is you have to connect source of C with drain of D and drain of E. So here you can see source of C and source drain of D are connected. Only thing is you have to connect it with the drain of E, right? So like this you can connect. So can you guess why have I drawn this at the upper side and not in the downward direction? So yes, you have guessed it right, because this particular part has to be connected to the VSS. So if we are connecting this particular part at the ground side, there will be a short circuit created. So there will be a connection from here to here. See here, the source of drain and source of E are connected and they have been given to the ground terminal. So this connection has to be made here. So if you have to connect it in this fashion, so there will be a short circuit created. Hence I have drawn it in the upward direction. So here the final contact. So this is a stick diagram for the given expression. I hope everyone is clear with it, and if you have any doubt, please mention it in the comment box, and I will be able to clarify your doubts. And thank you for listening. Have a good day.